So as we can say, from 0 to 0.2 we call it as very weak, 0.2 to 0.4 is weak, 0.4 to 0.6 is moderate, 0.6 to 0.8 is strong, and 0.8 to 1 is very strong. Okay, what are the properties? Now before we come to the properties, let's understand the representation. If I am doing the correlation on a sample, I represent it with letter R. If I am doing it on the whole population, I represent it with a Greek letter which is known as rho. Okay, so be it R or rho, we can calculate it through various statistical softwares. SPSS, Stata, R are some of the common softwares which are used. However, our aim in this lecture is not to help solve the problems of correlation through statistical software. That's actually pretty easy. You can just do the input and you would quickly get the result and the correlation based on whatever method you want. But our aim is to understand where to use what kind of correlation. That's extremely important. In which scenario, what kind of correlation technique would be used, and the basic formulas and how it is derived through hand or manually is the basis to understand this process. Okay. So some important key highlights before we understand into the depth of the correlational concepts. The first thing is, as I said, it varies from -1, 0 to +1. 0 shows no relation, +1 shows positive relation, -1 shows perfect negative correlation. And then closer values to 0 are weak correlation, values closer to the extremities -1 and +1 are strong correlation. Next important thing is correlation is unit free. For example, on one side I have height of the child which is in centimeters. On the other end I have weight of the child in kilograms. Now when I am trying to have a correlation between those, the height and the weight, one is in centimeter, the other is in kilograms, but my result is unit free. Okay, so I do not require that both the x and the y variables should be on the same scale. They can be on the different scales and still I can find a correlation. The correlation which is derived is unit free. There is no unit for the correlation. Extremely important to understand. The next is I can label whatever as I want. For example, if it is height and weight, I can label height as x, weight as y, or I can label height as y and weight as x. There is no problem. I can label either of those as x and y. Okay, my result would remain the same. It won't matter. The next important thing is what would happen. Let's say the number of hours you study and your performance. Okay, so number of hours you study and your performance, I am plotting those on a graph. So this is the result that I get. All of the values along the positive correlation on a higher note. Okay, so higher the hours of study, better is the exam result. Now out of this I pick up only few values which are on the very fine extreme. I don't take out all the values which are dispersed, but very few samples I take from this, which shows people who are studying for extremely higher hours and their result. Clear? So for example, in the first case, I find out, understand this concept very carefully. In the first case, I am trying to find out the relation between hours studied and exam result. Okay, I say that there is a correlation of 0.8. That means there is a very strong correlation. The more number of hours you study, the better you perform in the exam. A strong correlation and a positive correlation. As the hours increases, the exam result increases. Clear? Now, from this sample, understand very carefully, from the sample that I have taken, I pick a further small sample which shows only the people who are studying for extremely higher hours. So I am taking now only long hours studied, not all students studying for all range of hours, but only those students who are studying for higher hours and the exam result. Okay. Now I plotted. So from all these values, I take just few values and then I plot it. And I find a relation of 0.5 which shows a relatively dispersed curve. What does that mean? This means that in the initial stage, when I say as you increase the hours, your exam result would increase, is efficient. But if I'm studying for 9 hours, I'm securing let's say 80%, and then I'm studying for 10 hours, I'm securing 82%. That means the correlation goes weak there. Okay. So in the second case, my correlation goes weak, the slope becomes less steep, and there is a lower correlation that exists between the two things. Clear? The next is, whenever we are doing correlation, it's a good idea to draw a scatter plot diagram. How to draw a scatter plot diagram we have already understood in the past class. Just a quick recap. It's a graphical representation between the two variables, only applicable when there are two variables. Clear? So when there are two variables, I do a graphical representation. Usually on the x-axis, I take the explanatory variable, which is the independent variable. On the y-axis, I take the dependent variable or the response variable. So here we have the dependent variable and here we have the independent variable on the x-axis. And I draw a relationship. Usually under a Pearson's correlation, we have a linear relationship. Okay, and it should not be a non-linear relationship. Next important thing about correlation is, correlation should not be equated with causation or cause. Okay, if I say there is a strong relationship that exists between x and y, this does not mean that x causes y. Be very clear. There is a relation that I am studying for higher hours and I am securing good marks. But this does not mean that because I am studying for higher hours, I am getting higher marks. There can be various confounding variables associated. Confounding variables are what? Those are those variables which are not visible in the study but present. That means it could be intelligence, it could be dedication, it could be the concentration while you are studying, and those variables are not clearly mentioned in the study, but they are also responsible. So to repeat again, what do we understand here? We understand that correlation shows a relation between x and y, but it does not imply that x causes y. It's not about causation, it's about correlation. Very important, extremely important. It does not say that x causes y. Is not the case. It just says x has a relation to y. Clear? So that's another very basic fundamental concept that you need to know.